Hello everyone, welcome back to my YouTube channel. This is Filipino explaining. So in this video we are going to look at or to discuss Einstein's equation of photoelectric effect. So before I start explaining Einstein's equation of photoelectric effect, I would like to remind you that if you are new to my channel, if you are seeing me for the first time, or you have been seeing me but you have not subscribed to my channel, kindly consider subscribing to my channel, and please don't forget to hit a bell notification so that the moment I will be uploading a new video you'll be getting notified. Kindly do subscribe to support my efforts. Okay, so let's look at Einstein's equation of photoelectric effect. As the name itself implies, Einstein's equation was brought about by this man called Albert Einstein. I do believe that you have ever heard about this Albert Einstein. Albert Einstein was a German American physicist. In fact, theoretical physicist. If I say German American, I mean he was born in Germany, but sometimes afterwards he moved to America. So let's look at Einstein's equation of photoelectric effect. Enjoy. Einstein's equation gives the energy of the electrons emitted during the photoelectric effect. It is derived as follows. Suppose the work function of a metal metal surface is W naught. The threshold frequency F naught for light that will just eject an electron from the surface is given by this. W naught is equals to Hf naught, where W naught is the work function, H is the Planck's constant, and F naught is the threshold frequency. The energy of electrons ejected by a light of frequency F, now we have threshold frequency and this frequency, which must be greater than the threshold frequency. This frequency must be greater than the threshold frequency this one, F naught. So we have energy E is equals to Hf minus work function W naught, which is the same as Hf minus, we have said that W naught is Hf naught. So this work function can be represented by Hf F naught. Are you there? This energy is the kinetic energy of the emitted electrons. So Ke, this energy is the kinetic energy, is equals to Hf minus Hf naught, and kinetic energy is given by a half mv squared, which is equals to Hf minus Hf F naught. Now remember, this m is the mass of electron. So a half m mass of electron, we add a e there, v squared is equals to a Hf minus Hf F naught. And therefore, we can rearrange this equation, or we can leave it that way, such that we make Hf the subject to the formula, and we say that Hf is equals to a half MeV squared. Since this is a negative, if it crosses the equal sign, it becomes a positive HF naught, which is the same as HF is equals to HF naught plus a half MeV squared, where H is the Planck's constant, F is the frequency, H is the Planck's constant again, F naught is the threshold frequency, and then M is the mass of electron, V is the velocity. And this is the Einstein's equation of photoelectric effect. Hope you understand. Okay, so Einstein's equation may be understood in terms of the conservation of energy. I mean that the energy of the instant photon, HF, remember the energy of a photon is given by HF, is transferred to the work done in removing the electron from the metal surface. So HF naught plus the kinetic energy of the electron. Einstein's equations in the form this one can also be written in this form. I mean that I have MeV squared is equals to HF minus HF naught. We can still factor this out with H outside. We can leave it this way. But this is the Einstein's equation of photoelectric effect. So let's look at one example where we can use this Einstein's equation in calculations or numerical problem involving or engaging Einstein's equation of photoelectric effect. Example. So here's a problem that says the minimum frequency of light that will cause photoelectric emission from a certain metal surface is 5.25 times 10 raised power 14 Hz. When the surface is illuminated by another type of radiation, electrons are emitted with a maximum speed of 7.25 times 10 raised power 5 meters per second. Calculate A, the work function of the metal surface. So let's work it out. See solution. So you have been given the minimum frequency of light that will cause photoelectric emission of a certain surface is 5.25 times 10 raised power 14 Hz. So that is threshold frequency F naught. It's given as 5.25 times 10 raised power 14 Hz. Then when the surface is illuminated by another type of radiation, electrons are emitted with a maximum speed of 7.25 times 10 raised power 5. Maximum speed, that's V max of 7.25 times 10 raised power 5 meters per second. So you have been asked to calculate the work function of the metal surface. So work function A, work function W naught is given by HF naught. So you just write HF naught, where H is the Planck's constant and F naught is the threshold frequency. So Planck's constant is also always given by 6.63 times 10 raised power negative 34 joules seconds. So we are multiplying by the threshold frequency given in the question, 5.25 times 10 raised power 14 Hz, and it gives us 3.481 times 10 raised power negative 19 joules. in 4 significant figures. B. You have been asked to calculate the maximum kinetic energy of the emitted electrons. I've said that this term here is for kinetic energy. So the maximum kinetic energy, Ke maximum, will be given by this one here, a half MeV squared, where Ke max the kinetic energy, maximum kinetic energy. Me is the mass of an electron in kilograms. Then V is the maximum speed. Now we have a half times Me, mass of electron. Mass of electron is given by 9.11 times 10 raised power negative 31 kilogram times velocity squared. V maximum 7.25, it's here given the question, times 10 raised power 5. It is meters per second but squared. Are you there? And now we have our answer as 2.39 times 10 raised power negative 19 joules. Negative 19 joules. Hope you understand. So this is the maximum kinetic energy, and this is the work function. Number C of the question, it's asking us to calculate the frequency of the second source. Now this frequency F, this one, this F, I've said the whole of this term gives us the work function. Are you there? The whole of this term gives us the kinetic energy, and this gives us just energy. Are you there? So here, this is H is for Planck's constant, and this F is what the question is asking us to determine or to find or to calculate the frequency of the second source, this F. So here is where we will apply the Einstein's equation of photoelectric effect, and we say, this is C, we say that HF, this HF is equals to HF naught plus a half MEV squared. But we have said that HF naught is the work function. So HF is equals to work function plus a half MEV squared. I have said it is kinetic energy plus Ke. But from our question, what is from what we have worked out, what is our work function? Our work function is here, this one. Are you there? So we just substitute it here. Are we there? So we just write 3.481 times 10 raised power 19 joules plus kinetic energy 2.39 times 10 raised power negative 19 joules. Are you there? Are we there? This is this one. Then the whole of this is kinetic energy. So up to that point, we say we sum up this one, these two, and we get that HF is equals to 5.875 times 10 raised power negative 19. It is joules. Hope you understand. So to get the value of F, we are looking for F, we divide both sides by H by H. So F is equals to 5.875 times 10 raised power negative 19 joules over H. But what is our H? H is the Planck's constant. I've said that Planck's constant is given by 6.63 times 10 raised power negative 34 joule seconds. So it is 6.63 times 10 raised power negative 34 joule seconds, and we get our final answer as 8.861 times 10 raised power 14. But since we have worked everything in SI units, everything has been in SI units, and this is frequency, so the answer is automatically in hertz. And this is our final answer for the frequency of the second source. Hope you understand. Uh, um, uh, Hope you understand what I have explained, and it has been of beneficial to you. You have not just lost or misused your data for nothing. I hope you have understood, you have learned something new, or you have added knowledge to you. Kindly do subscribe to support my efforts. See you next time. Bye bye.